Thanks, Danny. That's pretty cool. I'll have to try out your challenge too. Hi, my name is Kat, and I'm a junior on the electrical subgroup. I've been part of RAGE for 3 years now, and have definitely learned a lot. From how to properly solder wires, to even operating a trebuchet. I joined RAGE because, well, robots are cool, and that's true now more than ever. Now that you learned a little bit about programming, let's move on to another approach for telling robots what to do: machine learning. Machine learning is a type of artificial intelligence, but we're not going to be making Terminator today. We're going to use Google's free online service, Teachable Machine, to train an AI to tell the difference between an apple and a banana. You can follow along at home using the link in the resources page, and if you don't have an apple or a banana, any objects will do, but you'll see why I chose these two in a second. First, you need to gather the data you're going to use to train the AI. Collecting data is an essential part of machine learning. If you've ever used a service like Spotify, you're probably familiar with this. It uses songs that you, and users like you, listen to recommend songs it thinks you're going to like. Adding data to Teachable Machine is really easy. Change the name of Class 1 to Apple, and click Use Webcam to take about 50 different pictures of your apple. For Class 2, do the same with the banana. Now you're ready to train the machine. Or rather, it's ready to train itself. Essentially, it looks at all the pictures of what you told it was an apple, and all the pictures of what you told it was a banana, and looks for patterns to identify the differences in the images. Then it quizzes itself with the same image to see if its identification matches the one you defined. This process is repeated until it's confident it can tell the difference between apples and bananas. Now, it's time to put it to the test. Show it a picture of your apple. The display on the right will show you both what the machine sees and what it's thinking. First, I showed it an apple, and with 100% confidence, it was like, that is an apple. Next, I showed it a banana, and it was like, that's a banana if I've ever seen one. Don't worry, that's not the end of the experiment. That would be pretty boring. No, we built this little machine so that we could break it. So that means it's time for the next step. Lemons. What do you think will happen when we show the computer a lemon? An app banana? Yeah, that makes sense. Keep in mind that the machine determines what the image contains using patterns it found in its training data. We only trained it on apples and bananas, so it's only going to know how to pick between those two. A lemon is the same rough size and shape of an apple, but it's the same color as a banana, so the machine gets really confused. So what happens when we show it other things? This toy WALL-E is about 95% banana. But WALL-E isn't a fruit. So why does it think he's a banana? Well, it's for the same reasoning as the lemon. WALL-E has similar patterns to what the machine learned means it's a banana, mostly the color yellow. It doesn't matter that WALL-E's not a fruit, because the computer doesn't know what a fruit is. In fact, it doesn't really even know what an apple or a banana is. It just knows to look for patterns and either shout apple or banana, depending on what patterns it finds. This is pretty cool and all, but what does it have to do with robotics? Well, when designing, building, and programming a robot, you have to really consider what you want the robot to do. You can make a robot that's really, really good at sorting between apples and bananas, but if you also need to sort lemons, then you're kind of out of luck. Machines are only as smart as we make them, so we have to consider everything it might encounter and what it might have to do, because it's not going to know if we don't tell it.